So in the last video, we looked at the discriminant, and we looked at quadratic equations of this format. And the discriminant, b squared minus 4ac, when that's less than 0, we found out that there were no real roots, no places where the curve crossed the x-axis. When b squared minus 4ac is equal to 0, we had one repeated root, okay, just crossing the x-axis there at one point. And when b squared minus 4ac is greater than 0, we had two distinct roots, two different roots, curve crossing at two different places there. So what I'd like to do in this video is I'd like to try and understand why these are the case here. So why is this going? I know we can look at the graph and we can see, oh well, if it doesn't cross the x-axis, then it has no real roots. Yeah? But I'd like to look at it in slightly more detail. And to do that, I'm going to have to use the quadratic formula. So I'm going to write this out. Minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. What you should notice that the discriminant appears inside the quadratic formula, just here. Okay? And if we think about it, when the discriminant is less than 0, or when it's negative, then, as you know, we can't take the square root of a negative number in the real world. Okay? So we're not going to get any real roots, any real solutions to this equation. And you might be wondering why I keep on saying the word real. Okay? Because actually you can take the square root of a negative number in the complex world of mathematics, in the imaginary world of mathematics. So actually, when I keep saying that there are no real roots, there are in fact two complex roots. That's not something that you need to know for your course, but it might be something that interests you. Okay, so there are no real roots, but there are two complex, or you might like to think of them as imaginary roots. Okay, what about when b squared minus 4ac is equal to 0? Well, if this is equal to 0, then we get the square root of 0, which is 0. So that means that we just get x equals minus b plus or minus 0, which we don't need to include, divided by 2a. So you can see that we only get what looks like one root. However, this root is repeated twice over. Okay, we do again have two roots. Okay, there are two roots, but it's just the same one repeated twice over. Okay, so we say one repeated root. Okay, and when b squared minus 4ac is greater than 0, you can see that this is going to be bigger than 0. Let's say, for example, it's 25. Say, then we're going to get the square root of 25, which is 5, and we're going to get two distinct, different roots. Okay, so in this case, we do get two roots as well. Okay, two distinct roots. Okay, so my main point, or one of my main points, is that when you solve a quadratic equation, there are always two roots. You can see that there are always two roots, but there aren't always real roots. Okay, when b squared minus 4ac is less than 0, there are no real roots. Okay, but that does mean that there are two complex roots. When b squared minus 4ac is equal to 0, then again there are two roots, but it's one root repeated twice over. It's the same root. Okay, and when b squared minus 4ac is greater than 0, then you can see we have two distinct roots. Okay, so I hope that sheds some light on the quadratic equation and gives you a slightly better idea about how the discriminant works and what it's all about. Thanks a lot. Bye.